What is up, everybody? So we are into 9.5, which is dealing with tangents. So not the type of trig tangent, okay? Tangent as in you can touch it. So if something's tangible, it is touching, all right? So that is the tangent we are referring to now, right? So a tangent is a line that intersects a circle at exactly one point. So it looks like that right there. So even though it looks like it's touching the circle in multiple spots as that blue line passes through that black arc of the circle, it's technically only touching it at one singular point. So think about a basketball sitting on the ground, right? That is a very good example of how the ground is tangent to the basketball, okay? So a point of tangency is where the tangent touches the circle. So C is the point of tangency within this diagram. All right. So there's a couple different theorems that we're going to go over today. They're pretty straightforward, pretty simple. So the first one is if a tangent line is a line is tangent to a circle if and only if it is perpendicular to a radius at that point of tangency. Okay, so before we get to the new diagram on the right, if I were to draw a radius from A to C, that has to make a right angle, aka being perpendicular. All right, so if a radius is drawn from the center to the point of tangency, it has to be perpendicular to the tangent line. So the green has to be perpendicular to the blue. So in our new diagram, that would have to be a right angle, okay? And as you can imagine, where right angles are present, so is the Pythagorean theorem with triangles a little bit, okay? The next theorem. So notice how I have my circle and I have a red dot outside the circle. We call that an exterior point because it's on the outside of the circle. Now, if I were to draw tangents from that exterior point, kind of looks like an ice cream cone, right? Or a satellite in space giving off its signal. If two segments from the same exterior point are tangent to a circle, then the segments are congruent, right? So if two tangents, so if this tangent and this tangent are both drawn from the same exterior point, then those tangents are congruent. And guys, this right here is kind of like how satellites are going to emit a signal, right? So imagine that circle is the Earth and our satellites are orbiting around the Earth. They can't pass signals, right, like on angles, right? Everything is traveling in a straight line, least resistance. So the signal is going to travel the same distance to the north as it is to the south. And that's kind of how signals get transmitted. Now, the way that signal can be relayed to another side of the Earth over here is maybe there's a satellite in the space. So it would travel from here to here, up to here, and then down to here. And then obviously satellites can communicate with each other as well. So if I had another satellite, I could just bounce the signals around. Okay, but that's kind of how transmission works, right? To go from, besides hardwired stuff like lines that cross the ocean or across the country, right? That's just a really cool way how satellites get us information, even though the source of the information might be on the other side of the world. Right? Pretty cool stuff if you ask me. So those are the two main theorems, all right? A radius is perpendicular to a tangent, and if two tangents are coming from the same exterior point, that makes them congruent. Let's look at some examples. So is KL tangent to circle J? Okay, so they're asking, is this yellow segment tangent to our circle, right? Now, if it's tangent, then this would be true because 8 is a radius. So we have to check to see whether or not this is making a right angle. Now the way that we do that, Pythagorean theorem. So we have our two legs, 8 and 15, so 8 squared plus 15 squared equals. Now the 9 is referring to this yellow segment right here. So the question is what is this length here? Well, that's a radius. What's our radius? JK, 8, so that means that this is also 8 right here. So our hypotenuse is this entire yellow thing now, which would be 9 plus 8, so 17. So quickly using our calculator, 8 squared is 64, 15 squared is 225, 17 squared is 289, so 225 plus 64, 289 equals 289. The answer is yes. KL is tangent to circle J because it's perpendicular to that radius in green. Okay. Next example is kind of changing it up. It's saying JH is tangent to circle G, solve for X. Now this problem, I will say, is a little algebra heavy. So let's set it up. So we already know that the green is tangent to the circle. So that means green and yellow are forming a right angle. So we have a right triangle. Now our two legs of our right triangle are x and 12. So Pythagorean theorem, x squared plus 12 squared equals. Now our hypotenuse is this entire purple length right here. Now we know that from J to the edge of our circle is 8, but from the edge of the circle to G, that's also x. So our hypotenuse length is x plus 8, and we have to square that. So let's do some algebra. X squared plus 144 equals x plus 8 squared. Do not just do x squared plus 64. X plus 8 squared is x plus 8 times x plus 8. So what happens here is we have to do FOIL. X times x is x squared. X times 8 is 8x. 8 times x is 8x. 8 times 8 is 64. Combine like terms, x squared plus 16x plus 64. So that is what goes in when you square x plus 8. From this point, I can now cross these off because they are the same on both sides. I can subtract 64 to the left, so 144 minus 64 is 80, so get 80 equals 16x. I can divide 80 by 16, so x equals 5. So our radius of our circle is 5. Please don't make the mistake of doing this math incorrectly. X plus 8 is not x squared plus 64. You have to FOIL the whole thing out. It is a binomial, x plus 8 times x plus 8. Please, please, please don't make that mistake. Okay? Solve for x again. So maybe pause this and try it on your own. Here we go. I know that that radius is x, so I have x squared plus 4 squared equals x plus 2 squared. X plus 2 squared is x plus 2 times x plus 2. That becomes x squared plus 2x plus 2x plus 4. So x squared plus 4x plus 4. So I have x squared plus 16 equals x squared plus 4x plus 4. X squareds go away. Subtract the 4 to the left. 12 equals 4x. X equals 3. Ta-da. Okay, looking at this problem here, we have an exterior point with two tangents. We know that both tangents, because they're tangent to the same circle, they have to be equal. So all we got to do is x plus 15 equals 2x minus 15. Add the 15, subtract the x, 30 equals x. Those ones are pretty straightforward and pretty easy. Okay. Last problem. Okay, so the first thing it says is solve for x. So I'm looking down here. So that's going to be x plus 3 equals 4x minus 9. So again, that's because both of those tangents are coming from the same exterior point. Subtract the x, add the 9. 12 equals 3x. So x, whoops, not 12x. 12 equals 3x. So x equals 4. The next thing they ask is, what is the perimeter of triangle JKL? JKL. So let's look at this. I know that JO is 12. So that means that JM is 12. I know that KM is 7. So that means that KN is also 7. I can then take my 4, plug it in right there. 4 plus 3 is 7, which means that J or LO has to also be 7. So all I have to do to get my perimeter of my triangle is 12 plus 12 plus 7 plus 7 plus 7 plus 7 equals my perimeter. So I know 12 and 12 is 24. I know 4 sevens is 28. So 24 plus 28 gives us 52. So our perimeter is 52. That's all she wrote. Lesson is all done. Good luck.